Hello students, my name is A.Ram Reddy. I have done my graduation from IIT Patna and I have been associated with askIITians from past 4 years. Now we are going to learn about chemical kinetics, that is the kinetics of chemical reactions. As we already know that the world is full of many reactions and all these reactions will occur at different speeds. So how the speed of these reactions are varying and what are all the factors that will influence the speed of these reactions and how the reactants are getting converted into products and how the energy of the reactants are varying during the progress of the reactions. So first let's start with the discussion.
So try to be tuned in. We are starting off the chapter, that is chemical kinetics, that is the kinetics of the chemical reactions. So let's see what we are going to learn in this chapter. First, what will you learn in this chapter, in this particular chapter? First, introduction about the chapter, then the reaction rate, the rate law, and order and molecularity of the reaction, and also the factors which will influence the rate of the reaction. And then we'll learn the integrated rate laws of the zero and first order reactions and the calculation of half-life periods, which is followed by the collision theory of reaction rates. And in collision theory, we are going to learn the energy factor and the orientation factor. And finally, we are going to learn how the temperature affects the reaction rate as well as the rate constant, which is given by the Arrhenius equation. So in nature, we have so many chemical reactions, like some chemical reactions takes less time to complete and some other chemical reactions take more time to complete. So the speed or the rate at which the chemical reactions progress is different. Different reactions will occur at different rate. So how fast the chemical reactions go? What about the speed of the chemical reaction, and what are all the factors that will influence the speed of the reaction? And during the reaction, like the reactants are getting converted into products. So what is the mechanism, like what are the steps through which the reactants will form the products? That is the mechanism of the reactions. What about the mechanism of the reaction? So all these are the questions that we have in our mind about chemical reactions. So let's find the answers for all these questions. So previously you might have studied the thermodynamics, the concept of thermodynamics, and is it thermodynamics is not sufficient enough to answer all these questions? Let's see what is the information that is given by thermodynamics, and will it answer about the kinetics of the reactions or not. So in thermodynamics, what we learn is it will only tell us whether a reaction takes place under a given conditions or not, under given conditions of temperature and pressure or not. So we know that if delta value, the free energy change is negative, then the reaction is spontaneous, and otherwise if delta G is greater than 0, then the reaction is non-spontaneous, which is non-feasible. So it will only tells us whether a reaction occurs under given conditions or not. But if at all a reaction occurs, and how fast or how slow the reaction will occur is not given by the concept of thermodynamics. And even the thermodynamics explains, so when the reactants converted into products, what is the energy change, the delta H? Is it positive or negative? So exothermic or endothermic information is given by thermodynamics. So it only concerns with the initial and the final states of the reacting systems, and it does not provide any information like how the reactants will pass through the final state. It does not provide anything about the reaction mechanism. So the thermodynamics gives these two information, but these questions are still unanswered. We don't have the answers to these questions. So what is that thing that is going to answer all these questions in our that are raised till now? So it is chemical kinetics which is going to provide the answers and explanation for all these questions. So this is the purpose of learning chemical kinetics and the importance of chemical kinetics. It is going to give us the explanation about how fast do the chemical reactions go, and what are all the factors that will affect the speed of the reactions. So let's learn more about it. So chemical kinetics is a branch of science that deals with the rate of reaction, that is the speed of the reaction, and also what are all the factors that will affect the rate of reaction, the factors, about the factors, and also the sequence of the steps through which the reactants pass through the final state, that is products, that is called reaction mechanism. So it is going to give information about all these things, and it also explains like what is the amount of the products formed and what is the amount of the reactants consumed during a time interval, and what are the factors that need to be controlled in order to get the maximum yield of the product, which is important for industrial applications. So all these things can be explained by the chemical kinetics. Okay, so in nature we have so many reactions. So is it possible to determine the speed or the rate of every reaction that is occurring in nature? So this is one question that is raised now. So before answering these questions, let's know more about what are all the reactions are there in the nature, and how these reactions are classified, and let's learn more about the reactions, and then we'll see is it possible to determine the rate of every reaction or not. So let's take it further, the concept of the chemical reactions. So since the different reactions are occurring at different rate, so if I take a particular reaction, say A2 molecule is reacting with B2 and it is giving 2AB. Okay, so this is a chemical reaction. For example, if I take, so say this is A plus B, which is giving 2AB, that is A which is bonded to B plus A which is bonded to B. So if you see in this reaction, the bond between the reactant molecules is broken. So this bond is broken and this bond is broken, both of these bonds are broken, and two new bonds are formed. This is one bond that is formed between A and B, and this is one more bond that is formed between A and B. So during a chemical reaction, the bond between the reactant molecules need to be broken and new bonds are formed between the products. So the fastness or the slowness of the reaction is going to depend upon how strong these bonds are and how many number of bonds are there. So that is the strength of the bond and also the number of bonds going to decide like how fast or how slow the reaction takes place. So if strength is more and if there are more number of bonds, then the reaction will take place at relatively slower rate, and if the strength is less and number of bonds are less, then the reaction will take place at relatively faster rate. So depending upon the rate, the reactions are classified into three types. One is instantaneous or extremely fast reactions. Second is the reactions which are occurring at extremely slow, and third is the moderate reactions. So as a whole, the reactions can be classified into these three types. So let's take it further to discuss, to understand more about it. First is the instantaneous or extremely fast reactions. So as the name indicates that the reactions are extremely fast, which are almost instantaneous, which will normally takes around 10 power minus 10 fraction of seconds to complete. So one such example, if you see, if a drop of silver nitrate AgNO3 is added to a solution of NaCl, then the precipitate of AgCl precipitate will be formed within a fraction of seconds along with NaNO3. So the reaction is also mentioned here. So if you see here, the solution, the sodium chloride solution contains sodium ions plus chloride ions, and similarly the silver nitrate solution contains silver ions and nitrate ions. So as soon as you add these two solutions, you will get the white precipitate of AgCl, that is silver chloride, very instantaneously, almost instantaneously. So this is a reaction which is occurring at very fast rate. So why this reaction is occurring at very fast rate? Because here there are no bonds need to be breaked. Here there is no any requirement of breaking bonds. Already these are individual species, so the moment we add, this precipitate of silver chloride will be formed, as you can see in the picture. So the half-life of this ionic reaction is around 10 power minus 10 seconds. So some other examples of these instantaneous reactions are free radical reactions. You know that free radical reactions are very fast. The free radicals are extremely reactive species, so they'll quickly react, and the reactions of the free radicals are also very fast. Okay, so this is the one class of reactions which are occur at very fast rate. So since these reactions are occurring at very fast rate, it is really difficult to understand the kinetics of these reactions, because since the reaction is completing in a fraction of seconds, it does not give you enough time to measure any of the changes during the reaction time. So it is very difficult to study the kinetics of these reactions. And the second class of reactions is extremely slow reactions. These reactions will take months, years together to show any measurable change. So such examples, like one of example is rusting of iron, where the iron or steel reacts with oxygen in presence of moisture, the rust will be formed. So it is a very slow reaction which will take months or years. Similarly, the reaction between hydrogen and oxygen at room temperature is also very slow reaction, and the half-life of these reactions are of order of several years, several months. Since these reactions are very slow, extremely slow, it is difficult to study the kinetics, because it takes months together, years together to show any measurable change during the reaction. So this is difficult to study the kinetics of these reactions. And this is the second class of reactions. So the last one, the third class of reactions, is moderate reactions. Moderate reactions are nothing but the reactions which are not too fast or not too slow, which will occur at moderate rate or at measurable rate. So these reactions will occur at measurable rate. And the half-life is of the order of minutes, hours and days. Here instead of taking the full complete life, half-life is taken, because half-life is can be calculated easily as compared to complete life. So this half-life is used to compare the rates of reaction. So if half-life is less, then the reaction is fast. If half-life is more, then the reaction is slow. And some of the examples of moderate reactions include the decomposition of hydrogen peroxide, where hydrogen peroxides will decompose to water and oxygen. And similarly, decomposition of nitrogen pentoxide is also a moderate reaction which occurs at moderate speed, not too slow, not too fast. And decolorization of acidified potassium permanganate is also a moderate reaction. And hydrolysis of ester, the inversion of cane sugar, the reaction between nitric oxide and chlorine. So all these are some of the examples of moderate reactions. So in chemical kinetics, we are going to study about the kinetics of only the moderate reactions, because since these reactions are not too slow and not too fast, so the reaction gives time to calculate any changes during the reaction time. So in chemical kinetics, we are going to study only the rates of moderate reactions. So it is only possible to study the kinetics of moderate reactions.
So students, in this part we learnt about the importance of chemical kinetics and also the classification of chemical reactions. So I will be using one term repeatedly throughout the end of this lecture, that is rate. So to know more about what is meant by rate and how do we define it for a chemical reaction, stay tuned in for my next part.